Cool. So basically the domain is how far the graph goes across the x-axis, whereas range is how high up and down the graph actually goes. Alright, so let's now go through and have a little bit of a look at a worked example on how to work with domain and range and sketch the graphs of functions over a given domain and range. Let's check it out.
Alright guys, so as you've just seen, today we're working with domain, range, maximums and minimums. Now, as you've just seen during the last little presentation, there's a number of things that you need to know when doing this. First of all, the domain is the distance across, basically how far it goes from one side of the graph all the way to the other. So if you have a look down at this graph over on the right hand side, you can see that this graph here goes all the way across from -7, starting at -7 down here, all the way over to 6, that is at this point here. So it's the furthest point across at the left hand side to the furthest point across on the right hand side, which, like I said, is from -7 to 6. Now, these points are included, so they're actually square brackets, and we'll come to that again in a second. The range is how far up and down. So if we have a look here, the range in this graph goes all the way from -9 at the lowest point to 8 at the highest point. So the range is -9 to 8. Once again inclusive because these dots are coloured in. Now, whenever working with these types of graphs, we need to just consider the function notation. And you're going to see this more and more over the course of the next couple of years. So if we have a look at this, up until now we've just dealt with this part of the graph, that is f of x is equal to, and we've got the rule here. Alright, but now I've got a little bit more information that we need to be thinking about. So, we've got the f here at the very beginning. Now that's basically the name of the function. And the f will always be the same as whatever letters out the front of the brackets in the actual name of the function. So if you've got f of x, it'll be f. If it's g of x, you're going to have g. It basically just needs to be the same thing. Alright, the next part along is the domain. So this actually here in our brackets tells us how far the graph's going to go from in terms of from left to right. So for this graph here, if I was to sketch it, the graph's going to go from -4 along the x-axis all the way to 1 along the x-axis. Now over here, this is the codomain. This is probably one of the more tricky things to understand, because what it basically means is what value, once you substitute in your x values, can you get for y. And this is generally r, so you don't really have to worry about it too much. But basically what it means, if I substitute in -4, it can give me any real number for y. If I limited this and say made it from -2 to 5, if I substituted my x value of -4 and didn't fall within those range, well then it couldn't actually sketch the graph for that point. So yeah, basically the range has to fall within these values, and like I said, it's generally r, so you don't need to worry too much about it. Now over here, as you can see, we've got the f of x is equal to x minus 1x plus 2x minus 3. Well, this section here is always the rule, and f of x is what we've defined the rule as, and like I said, that'll always be the same as your f out the front, or whatever you've called it. If it's g of x, it'll be g out the front. Now, whenever we're working with these types of graphs, what we need to do is consider interval notation. So for example, we've got inclusive and non-inclusive. Inclusive means that the graph basically includes that point, and non-inclusive means that the graph doesn't include that point. Now, an example of what you might see for inclusive is if you see square brackets. Right? If you see some square brackets, it means that that graph goes through those points. So that might be, say, 3, 5. Means that the graph is going to go from 3 to 5 along the x-axis, and they're going to be included in those points. Greater than, less than. So you might also have, for example, 3 is x is going to be greater than 3 or equal to 3 and 5. So this means that x is greater than or equal to 3 but less than or equal to 5. So it means it's actually included. And the dots, well, the dots will always be coloured in, because basically it means it's included on the graph. So if it's coloured in, it means that it actually goes to that point. Whereas for non-inclusive, the brackets, they're going to be round, so you always know if the graph's not included in that point, because in the function notation over on the left hand side that you could see, you might have a round bracket. So that means if I had this, that is -4 to 3, it means that it actually doesn't go through the point -4, but it goes through the point -3.9999999. So it gets really, really close, but without actually existing at -4. Greater than or less than, well, I might have something like this. I might have -4, x is greater than -4, but less than 3. So, as you can see here, x isn't actually quite at -4, it's really, really close to it. So -3.99999 is actually going to be included in that section, but not -4. And x will be less than 3, so therefore x can equal 2.99999 once again, but it can't equal 3. And in terms of this, the dots, well, they're going to be a non-coloured in circle, because, of course, on the graph it doesn't actually include this point. So if it doesn't include it, well then it can't actually have any color above that dot. Now whenever we're working with these types of functions, we need to follow a few steps, as you can see up here in the top left hand corner of the screen. The first step, like always whenever sketching graphs, is to find the y-intercept by making x equal to 0. That's no different to what we've seen. Second step is to find the x-intercepts by making y equal 0. Once again, no different to what we've seen. Remember, if you've got one type of x, to use inverse operations, whereas if you've got more than one type of x, you need to factorize. Now step 3 is to find the endpoints of the graph by substituting in each extreme of the domain. So coming down to this function here that we've already looked at, where we're sketching the graph of f of x over the domain -4 to 1, what you would do is you'd substitute in x equals -4 and x equals 1 into this rule here. That will give you corresponding y coordinates, so therefore you can find out the endpoints of the graph. And step 4 is to use the CAS calculator to find any turning points, local maximums and minimums, and sketch the graph. Now in terms of local maximums and minimums, etc., a turning point here is called a local minimum because it comes down to a minimum point but then goes back up. And then over here you've actually got your absolute minimum, that is the lowest point on this graph that you've got. So as you can see, the absolute minimum will be lower than the local minimum. Sometimes though, your local minimum can also be your absolute minimum. That is if the turning point came all the way down here to its lowest point and then went back up. Now your absolute maximum, well that's your absolute maximum value, that will be the highest point of your range, and your local maximum is going to be a turning point where it comes up, doesn't quite reach the absolute maximum, but goes up and then comes back down.